All right, 0.6, systems of equations. These are all the skills that I found under Algebra 1 that we're going to do. It's basically the whole chapter of systems of equation, but this is all review. And so it might take us a little bit of time to get through all these, but most of these are going to be pretty straightforward. Some of these harder ones we might have to go over in class, but it's not that big a deal. They're just word problems, and I'll show you how to set them up. Pretty straightforward. So let's get right into it. Students will be able to solve systems of equations using either the elimination, substitution, or graphing method. Okay, so let's talk at example number 1 here first. Pretty easy. We're going to talk about first the substitution method. And it's exactly what it sounds like. You're going to substitute in one equation for another. You notice in this one, both of these equations, a system just means 2 or more equations, like a set or a group of equations. So both of these are already equal to y. So what we can do is we can just kind of like say, well, okay, they're both equal to y, so let's just say, well, then we know y equals y, so therefore the x plus 3 from the first y has to equal to 2x plus 5 from the second one, y. Well, now we can just use our basic algebra to solve this thing. So I'm going to subtract an x, subtract 5, subtract 5. Those would cancel out, those would cancel out. 3 minus 5 is -2. 2x minus x is just x, and x equals -2. We've solved for one of the variables. Now, again, we're going to substitute that back in. We could plug it into either one of these, but I think the top one is the easiest, right? So if I was to say y equals -2 plus 3. Well, what's -2 plus 3? Well, it's 1, so you get y equals 1. So the answer to this would be x is -2 and y equals 1, so -2 comma 1. Boom. So we could actually check this too. What you could do is you could plug it into the other equation, make sure it still works. I'm going to check it in green here real quick. So if y is 1, it is 2 times x, which is -2 plus 5. Is that a true equation? Well, you'd have -4 plus 5, and -4 plus 5 is definitely 1. So yeah, that works. There's our answer. So you're always going to get, you should have 2 numbers there. You should have an x and a y when you're doing solving for systems of equation. Okay, so I want you to try practice 1. But on this, before we do this one, I do want to point some things out. The last one was already solved for y, and this one is not. So we're going to solve these for one of the variables, and you have to pick which one you think is going to be easiest. Since both of the x's in both equations are already just, there's no coefficient other than 1 next to them, I think the x is going to be the easiest to solve for. So let's do the top row. The top row, if I was to rewrite that, I could add 2y to both sides, right? And if I was to do that, the top equation becomes x equals 2y minus 4. So that's kind of the first one. And then the second one we could do here, we could say, let's subtract y from both sides. And you get x equals -y minus 7. Okay, so sometimes you're going to have to do a little bit of work like that, but notice now they both equal x, and so now you could substitute one in for the other. In fact, actually, you don't have to even have them both equal the same variable. We could have, like, let's say I just did this one. I could right away say, okay, x equals 2y minus 4, and what I could do is I could just say, well, if that's 2y minus 4, and that's equal to x, I could just replace that x with the 2y minus 4 and solve it that way. So there's a few different ways to do it. It doesn't really matter which way you choose to do it, but I want you to go ahead and give it a try. See if you could solve this one out. And then check back when you're ready to check your work. All right, so like I said, what we could do here is we could just say, well, that's 2y minus 4 is just that x, so I'm just going to replace that x with 2y minus 4. So instead of writing x plus y equals -7, I wrote 2y minus 4 plus y equals -7. And then you just solve this equation down so you get till y equals -1. All right, well, now that I know y equals -1, I'm just going to take this and I'm going to plug it back in. And that's where I got, this equation here. And as you solve this out, now you get that x equals -6. So you have your answer that x equals -6 and y equals -1, so I wrote that in as a coordinate point because that's what it is. And then I also checked that. I checked that with this other equation over here, which says that x equals negative y minus 6. I could check it in any of these, but since x is already by itself, it's pretty easy to check here. So negative 6 for x, and then I have a negative in front of the y, and then when I plug y in, it's also negative, so it's a double negative turns positive, minus 7. So positive 1 and negative 7 makes negative 6 and negative 6, so yes, it does actually work. So that's the substitution method. All right, but let's go to the elimination method, and this is usually people's favorite. So let's solve each system by adding or by addition or elimination. So before we do this real quick, I want to just point out something to you. Let's do like a really simple equation. Let's say I said 1 plus 2, well that equals 3. And then let's say I said something like, I don't know, 5 minus 2. That also equals 3, right? And it's just kind of a coincidence that these both equal the same thing. Don't pay too much attention to that. Now look, we can actually add equations. So check this out. If I was to add these equations, look what happens. Just go straight down. 1 plus 5, well that's 6. 2 and negative 2, well, that cancels out, just becomes 0. And then over here, we have 3 plus 3, which is also 6. And look, that's a true equation as well. 6 plus 0 equals 6, or 6 equals 6. So you could do the same thing with equations that have variables to them. So if we take a look at this guy, and if we were to just straight up add these two equations, you'd see that you get 3x. The y's would cancel out, so positive y, negative y, that's just kind of a 0, and then 5 plus 1 is 6. Well, 3x plus 0 is just 3x, so divide both sides by 3, and you get x equals 2. And you can see how that quickly gets us to an answer. Now we use substitution from here. We're going to take this x equals 2, we're going to plug it into either one of these. I think the bottom one is probably the easiest one to plug it into. So I'm going to say, instead of x minus y equals 5, I'm going to say 2 minus y equals 5. And from there, we're just going to do some simple algebra. Subtract 2, I got negative y equals 3. Multiply both sides by negative 1, and you get y equals negative 3. Okay, so that means our answer has to be 2 comma negative 3, because our x and our y. Let's just check it. Let's check the 2 and the negative 3 at the first one. So if I was to do 2 times 2 plus negative 3 for the y, would that equal 1? Yeah, I'd have 4, I'd have negative 3. That certainly does equal 1, so this solution does work. I checked it. Okay, so that's elimination method. We eliminated, it's called that because we eliminated the y's, right? All right, so now on this next one, on practice 2, I want you to look at, and I want you to see, like, it doesn't quite eliminate like we thought, right? Like the last one, there was just a positive y and negative y. It was easy, but this one, not as easy, right? Because there's not just a positive x or negative x or a positive y, negative y. But just like we were doing with the equations before, we can change these equations. So I see that this y is negative and this one is positive. And so I'm going to use this, I'm going to cancel out the y, so I'm going to do something to the bottom equation first. What if I multiply the whole bottom by 3? Wouldn't that make this equation 9x plus 3y equals 21? Now let's just cross this one off. We don't need it now. Essentially what I did is I just tripled this second equation to make this one. Well, now look at these two equations. So now the negative 3y and the 3y, now those will just cancel right out. So I'm going to change colors here so you can see the next step. So x and 9x, that makes 10x. Negative 3y and positive 3y, well, doesn't that make 0? And 21 and 9, that makes 30. Well, that means that we have 10x equals 30. Divide both sides by 10. And x equals 3. Boom. Now again, we're going to take this and we're going to plug it back into any one of these equations. It's up to you which one you pick. I'm going to pick the top one. So if I plug this into the top one, you're going to get 3 for x minus 3y equals 9. And we're going to just solve for y. So I would subtract 3, I'd get negative 3y equals 6. Y equals negative 2. So 3 comma negative 2 is our answer. And we can double check it. We could check it. Heck, let's check it with this one that we crossed out. So 3 times our x value is 3, plus our y value is negative 2, and it should equal 7. Does that work? 9 minus 2 equals 7. Yes, that is correct. So that is a correct solution. A little bit tricky there. Just wanted to show you that other example. Normally I have you guys do the practice on your own, but I just wanted you guys to see that one. Okay. We're going to switch it around a little bit. I know that normally I do the examples, you do the practices, but I want you to take what I showed you in practice 2 about like multiplying a whole equation and apply that here. So you got these two equations. There isn't, unfortunately, these are both positive, so there's nothing that's just like one positive, one negative. But is there some way to quickly get these things to cancel out by multiplying it by? And 3 and 5 could work, but you'd have to multiply this equation by 5 and this by like -3. So we'd rather not multiply both equations. We'd rather just multiply one. And what I see here is that 6 and 3x, well, I can get 3 to look like 6. All I got to do is multiply it by -2. Multiply this whole equation by -2. And wouldn't that be -6x minus 10y equals -14? Okay, so now you don't even need the second equation. You have your two equations that'll nicely cancel out. I want you to use the elimination method to solve for the system. And do both. Don't just do the y or the x, do both. Go ahead and give that a try, and then and obviously pause the video, and then check back when you're ready to check your work. All right, so when you add these equations, the top and now this new one that we created together, the x's cancel out to get you 0. They eliminate. That's the whole idea. +3 and -10 makes -7. And 0 and -14 makes -14. So you got a nice little easy equation to solve here. Divide both sides by -7. You get y equals +2. Then I went ahead and plugged that into the top one. You could pick either one. I just didn't want to deal with all these negative signs, so I chose the top one. 6x plus 3 times 2 equals 0. That's 6x plus 6 equals 0. 6x equals -6. Divide by 6 and you get -1. So I got x equals -1, y equals 2. There's my solution, and then I just checked it in the equation that we canceled out. I like to check it in different equations. That way you can, really make sure that it's right. And yeah, there's our answer. Okay, so we've done substitution, we've done elimination. Now we're going to do graphing. But before we go to graphing, I just want to point out example 2 is 2x plus y equals 1, x minus y equals 5. All right, just kind of keep that in mind. Keep in mind the answer is 2, -3. You can flip back to it when you get there, because let's look at the first graphing question. And the only graphing question. Hey, it's the exact same equations. So we should get the exact same answer. Our method for doing it is going to be different. I just want to show you that the method doesn't really matter. You're going to get the same answer. But still, I want to just kind of show you that that doesn't really matter. The method isn't really the important part here. It's just that they all will give you the same result. But I like the graphing method because it actually shows you what's happening here, what a solution means. So to do that, let's convert both of these equations into something that we can actually graph. So as you look at this 2x plus y equals 1, this is in like standard form. And there's ways to graph it in standard form, but the easiest way for us to graph it is what we already know, which is slope-intercept. And so what I would do is I would just subtract this 2x from both sides, making this new equation be y equals -2x plus 1. And you know what? I'm actually going to do this one. I'll box this one in red because we'll make this the red line. Let's do this one in blue. I want to get the y all by itself. So first thing I'm going to do is subtract the x. That would give me -y equals -x plus 5. Then I don't want that negative sign there, so I'm going to multiply everything by -1, making this equation y equals +x and -5. And so that's going to be my blue equation. So now if we go over to our graph to graph these, we're going to see something interesting happen here. So let's graph the one in red first. -2x plus 1. So we start at 1, and we go down 2 over 1, down 2 over 1, down 2 over 1. And we could also go back 1 up 2, back 1 up 2 to fill in the whole graph, and so we have our red line. Okay, let's do the blue one now. Blue one is y equals x minus 5, so we're going to go down 5. And this one just has a slope of 1, so that's pretty easy. It just looks like this. Up 1 over 1, or back 1, down 1. Connect all those lines. All right, And what you can see here is there's something happening right there. There's an intersection point. Well, what is that point? That point is at 2, -3. That point where these two lines intersect on the graph is at 2, -3. And if you look back at example 2, that was our algebraic solution. That's what we found. So not only could you use algebra to solve this, you could also just graph these lines, and where they intersect is the actual answer. Algebra is often a lot quicker, but I think it's important for you to understand what's physically happening here with these lines and what that solution actually means. It's the point where these two lines intersect each other, where they touch each other. All right. Last thing here on the notes, describe the difference between 3 different ways of solving systems of equations. So we've gone over these 3 ways: graphing, substitution, elimination. Under what circumstances would it be best to use each? So I want you to think through, like, what would make each one, easier for what scenario. So, because, you're not always going to use elimination, you're not always going to use graphing, you're going to use the one that's easiest for each scenario. So what would make them easier? Like, what information would you need to make you want to use substitution or elimination or graphing? So, all right, I'll see you guys in the next video.